All right, in this video, we'll be discussing single board computers and their role in hobby electronics. We'll be talking about a number of single board computer models that have development board capabilities and what they offer compared to traditional MCU-based development boards. So, what is a single board computer? Well, the most basic definition is any computer built on a single circuit board. Instead of components being spread out across the motherboard, expansion cards, etc., and it's integrated as much as possible to fit that definition. Smartphones, tablets, and netbooks usually fit this definition, so most people already use at least one single board computer in their daily lives. The processor is usually ARM-based because non-ARM processors give off a lot of heat, which is why we have complex cooling solutions for them. Memory is usually soldered on and it's rarely upgradable, although it is DDR usually, much like your desktop or laptop, but it's usually a special kind called LPDDR or low power DDR. It's used in SBCs, including phones and tablets. Non-volatile memory that acts as a sort of hard drive is often a micro SD card, eMMC, or even sometimes an NVSe in an M2 socket. There are now expansion uh, hats and things for like the Raspberry Pi that will actually accept that. Input and output ports are usually limited, but usually you can expand this with a USB. I think most of the SBCs that I've seen have at least a couple of ports, but there are also some that just require you to plug in a hub. Um, Graphics capabilities are part of the whole system on a chip idea, and they're usually much more limited than a desktop or laptop, but they are becoming increasingly more powerful as time goes on. Since its ARM RISC approach, low power consumption is a thing. So you can often run it on power banks, rechargeable batteries, at least to an extent. Keep in mind, single board computers, especially as they get better and better, require more and more ampage. So you may run into problems if it can't provide that level of ampage. We're talking 2, 3, and even 4 amps these days sometimes. So in this picture, I have what I think is a Chinese clone of a Raspberry Pi 3. You can see the power port, HDMI, a headphone jack, Ethernet, the pin header, and the Ethernet. Okay, well, we've discussed ARM and RISC in a previous video, but just to recap, it's a CPU design with fewer and simpler instructions. So instructions require more steps, but it uses a fraction of the power and it generates a fraction of the heat. Most desktop and laptops are using x86. If it's old enough, Intel, PowerPC, Ryzen chips, and those are all systems, but they require a lot of power, sometimes upwards of 1,000 watts, and generate a lot of heat. Some laptops, especially netbooks, use ARM-based systems, and in fact, more recently, high-performance ARM systems are starting to be serious competition against traditional sys systems. The reality, though, is you have to have different versions of a program to be created if you want to support ARM versus x86 in the same way of PC versus Mac versus Linux. All right, I thought I'd go over a few points about the history of single board computers. I'm going to be very general here, though. 76 to 78, you saw systems made with MCS 85s and 48s, used for control systems, labs, early computer prototyping. By the end of the decade, you had 6800s and 68,000 single board computers, far more capable 16, even 32-bit stuff, industrial controls, and even some computing workstations. By the 80s, you had SCD bus and VME bus single board computers that are provided for modular applications and industry, and they started really using x86 or 68 100 or 1,000 base CPUs. By the 1990s, we saw a lot more x86 based single board computers, much more compact designs. The PC/104 standard was adapted, and slowly but surely, single board computers were becoming more PC compatible. You saw them kiosks, ATMs, a few other things. By the early 2000s, you started to see ARM processors being adopted for single board computers because they're low power. You had the Gumstick, the Beetle board, the Shiva plug, and Linux started to become an even more popular option for single board computers because you didn't have to deal with all the licensing and restrictions of Windows. Then finally, in the 2010s, not too long after the Arduino revolution, there was the Raspberry Pi revolution. It introduced low cost and low entry single board computers, the Raspberry Pi line, and it soon became a major aspect of entry level hobby electronics. And now in the 2020s, we've got hobby single board computers gaining in performance, and they're actually competing with PCs in some cases. So at this point, you might be starting to ask yourself the question, why can't I just use my phone? Well, a phone, tablet, or a netbook, it might use ARM and it might technically be a single board computer, but that's not the same as using a single board computer as a development board. GPIO functions are buried inside the phone and generally not accessible, and any customization work would probably just not be worth it. It would probably destroy the phone. Even operating systems customization require advanced knowledge, and even then, your phone might be locked to prevent these changes. However, you can incorporate your phone or tablet much like your desktop or laptop. You can use an IDE from it or use it to control. So you don't absolutely need a desktop or a laptop to access your development board, but it's probably a lot easier. You might be able to find a development board that uses something similar, if not the same ARM processor in your phone or tablet, but it's obviously been configured, often at the hardware level, to function as a development board. The reverse is somewhat true. Um, Cellular radio modules do exist, but you probably won't be able to build a smartphone or tablet in quite the same vein, or at least I haven't found any. In the same way that you can't just use basic components, electronics, to build yourself a desktop or a laptop. And if you could, it would not be worth the effort and expense. Um, Again, some interaction between the two, but neither can replace the other, at least not yet. Now we move on to the idea of single board computers as development boards. It can function as a development board, much like the ones built around MCUs. They are far more powerful, giving you so many more options since they are full-fledged computers. As a result of this, SBCs are quite a bit more expensive, ranging into the hundreds of dollars for some models. This makes a much higher entry point to hobby electronics. However, there are some budget options for a happier middle ground. The Raspberry Pi lines of CBCs are the most popular, but there's a number of alternatives. A lot of them use the word Pi because that in itself is not trademarked. So Orange Pi, Rock Pi, Banana Pi, Libre Computer, or at least the lay potato models are popular alternatives. Although they might be harder to find. Raspberry itself even has a budget line, the Zero. It's less powerful, more budget friendly. I want to say a 02W is maybe the equivalent of a lower end Raspberry Pi 3. I'm not entirely sure. Um, but they're a fraction of the price. You can use the pins directly. That's part of what makes it a development board. But it's useful to get a breakout board, maybe like a Pi Wedge that can attach to a breadboard. Makes it a little more accessible, because otherwise you have to dig around in the pies. And if you have it in a case, that's difficult. A lot of cases will have some kind of room to bring out ribbon cables and whatnot. Capabilities are still comparable to other dev boards, but you have so much more that you can actually do with it. But that comes with the price that it could be all the more difficult for beginners compared to more beginner friendly options. More recently, we've had hybrids. Some development kits now feature both a microcontroller and a microprocessor for a number of different reasons. The new Arduino Uno Q functions as both a single board computer and a more traditional MC-based development board. It uses an STM32U585, which is Cortex M33 based as a microcontroller, and a Qualcomm Dragonfly QRB2210, which is Cortex A53 as the microprocessor. But there's some other options that the Uno Q, 2 gig, 4 gig, and I think they're coming out with an 8 gig, varying prices, but it's all under $100. The STM32MP1 and 2 Discovery kits that run you like $100, maybe a bit more. Does something similar with a dual core A7 for the processor and a Cortex M4 for the microcontroller. It's a little bit beefier in some ways compared to the Arduino Uno Q. BeagleBone Black, it has both. Well, it has both in that it has a Cortex A8 for the microprocessor, and it has some real-time Crow processors, so not quite the same, but connected. I also found an expensive industrial dev board that uses a quad Cortex A53 and then a Cortex M7 for a microprocessor. Keep in mind, just because something has both of them doesn't mean two dev boards, kits, whatever, will operate in the same manner, have the same capabilities, or even be able to boot into a single board computer like with an operating system as we know it. Now here you've got an Arduino Uno Q, which looks just like any other Uno, especially the Uno Rev 3 Wi-Fi, but in fact it also has a microprocessor and is a hybrid single computer as a result. Now, the next question for a lot of people would be, well, can I run Windows on my single board computer? Because it's the operating system that most people are familiar with in addition to Android, iOS, and macOS. However, it is primarily built for x86 based processors, so you can't just throw a regular copy to most single board computers. There are ARM editions of Windows 10 and 11. However, it's very licensed to very specific companies for specific processors. And on top of that, they usually throw some emulation so x86 programs can run on ARM editions. Most official support that I have seen is for Microsoft products such as the Microsoft Surface tablets. There is an unofficial community support for installing it on Raspberry Pi 5, Orange Pi 5, and even the Rock 5B. I haven't really looked into it though. Another alternative is a chip like the Intel Atom series, although that is going the way of the dinosaur, which isn't technically ARM or RISC, but it's a low-powered x86 based processor. It used to be used on some netbooks and tablets. There's probably things that are comparable to that. But as I said, your options for a dev board running Windows very limited and or very expensive. And then we come to Linux. It's not just one operating system, it's an entire family of operating systems developed by Linus Torvalds as a free alternative to the expensive based Unix-based operating systems, and it's still part of the whole Unix-like mega family. It first came out in 1981 after 8 years of development, and there's been many different versions, distributions. It can basically run on everything from a cable box to a toaster, well, at least some toasters, and has even had influence on Mac OS, iOS, and forms the core of Android. Debian Linux and its offshoot Raspberry Pi OS, that's also been known as Raspbian, are popular along with Ubuntu, Armian, and Fedora, and they're all part of the whole Linux mega family. Some models, though, use their own Linux distribution, such as Orange Pi OS, Rockchip, Debian, and NVIDIA Jetpack. They can come preloaded for you on a like a micro SD card, or you can just learn how to download the OS, have some kind of interface, and simply put it on yourself. I recommend doing that. Although if you don't know how to do any of that, then it could be a bit of a learning curve. So you basically just use a computer or a phone, download, put it on the card, slap it into the computer, and then just boot it up. As you know, it also makes single board computers a great way to learn Linux, at least the basics. even if it might not have the same power as a desktop or a laptop. So you've got a whole other field of learning you can do other than just basic hobby electronics. It's mostly open source, so anybody can make things for it. So there's literally tens of thousands, maybe hundreds of thousands of programs. Some versions, though, can have a few proprietary features. Um, the general rule is if it exists, there is a Linux distribution for it, or at least within reason. Then we come to Android. It's often the default operating system for smartphones, tablets, and some other stuff. You're either running this or iOS. But it also, as I said, it has a close relationship with Linux because Linux is at the heart of it with a Linux kernel. Although Android is not technically Linux, Android is unofficially available for the Raspberry Pi 4, maybe even the 5, and they're with like Lineage OS, Terraria OS. I've never really looked into that, but there's some more official ports for like the Orange Pi 5, Rock Pi B, and the NVIDIA Jetson Nano. But it can be really janky and buggy, so unless there's official support, and it definitely won't be replacing your tablet or smartphone anytime soon. All right, so the question is, what do you want to buy? Um, you've got the old, you're not really going to find a Raspberry Pi 1 or 2, not even new old stock. Maybe eBay if you want to take a chance, but it's not really a reason. Raspberry Pi 3B Plus, I think you can still find some places. It can run you 50 to $90. But yeah, you're gonna have trouble finding even that nowadays. Raspberry Pi 4 was the first model where you could get it with different amounts of RAM. Um, I just included the 4-bit version, run you like $130, and that usually includes a kit with some essentials. Raspberry Pi 5 is the newest. You can get it in 4, 8, or 16, and that's going to run you anywhere from almost $200 to 250 to 300. How much RAM, I suppose, is up to you. I would probably spring for at least the 8 gig model if you want to use it. Really depends what you want to use it for, to be honest. Pi 02W run you about 50, $60, so it's a great entry into single board computers. Orange Pi's 4, 90 to 100, the 5 with 8 gigs of RAM, about 190, so it can be just a little bit cheaper. I didn't really find any kits for it, pretty much just the board. Orange Pi also has some other models. They have their 02W and 3W as well. The Arduino Uno Q has 2 and 4 GB models. Keep in mind it's a single board computer side. I would say maybe somewhere around a Raspberry Pi 0W, maybe somewhere between that and the 02. I'm not really sure. There's the Lay Potato for like $60, Rock Pi 125, or at least the 4C Plus, what I could actually find. Their banana only model of Banana Pi I could find went for 132. Now, as I've already mentioned, there's a lot of complexities with getting into a single board computer because it is a full-fledged computer. After all, you have many, many options for development usage. You've got a lot of full programming language options. Java, C, C++, Python are popular, but even shell languages like Bash are popular, Perl. It really depends if the language supports like the GIO pins and other stuff. Um, you got less heat, but you still got heat, and you'll need cool. You'll pretty much want cooling solutions. The older the model, the less important that'll be. But the newer model, I mean, they have bigger and bigger fans. Highly recommended. You're generally looking to keep the temperatures under like 70 Celsius. 60, 65 would be better. When you get to 80 and above, that's when you can start to see problems. Now, this is learning a whole new computer and possibly a new operating system, so it can be extremely overwhelming for people who are very inexperienced. Even the act of putting the operating system on an SDHC card can be very daunting. Some peripherals for MCU-based dev boards, they might still work, or you may need to make adjustments. Computer peripherals, keyboards, mice, web cameras, printers, uh, scanners, etc., will probably work as long as drivers exist for them. And in some cases, the device is generic enough that it'll just work. There's a lot fewer simulators. I haven't really found, well, you can go with an 886 based version of an operating system on a virtual machine. So if you learn like Debian Linux, the commands and everything will pretty much be the same. Um, QEMU, it apparently has some Raspberry Pi support. I'm going to look into it, but nothing as far as I can tell simulates like GPIO pins, physical interfaces, etc. All right, I've done a lot of talking, so I'll wrap things up and let's do some recap. Single board computers, or SBC, they're loosely defined as an entire computer on a single circuit board. It encompasses types of development boards, your smartphone, tablets, netbooks, etc. Most use ARM architecture with RISC, uses a lot less power, generates a lot less heat, uses the power very efficiently, far less heat compared to desktops, laptops, phone tablets, netbooks, that you can't really turn them into development boards for many reasons, hence why specialized SBCs actually exist. There's different types that can run different OSs. However, several Linux distributions are popular. Raspberry Pi OS, also known as Raspbian, Debian, Fedora, Ubuntu, they're all popular. There are ARM versions of Windows, but they're for specialized licensed products like Microsoft Surface tablets. Android does use a Linux kernel, and you can put Android on some SBCs, but support and quality are pretty mixed. SBCs are more expensive than MCU boards, so they can range from the cheap end of 30, $40 to upwards to $300 or $400. And there's industrial ones that blow past the roof, but you probably won't be getting those. Raspberry Pi and Pi Zero are popular. There are alternatives: Orange Pi, Rock Pi, Late Potato, etc. Hybrids are becoming popular, such as the Arduino Uno Q, that combine microcontrollers and microprocessors. Well, until next time, have a good one.